Precisely.
Hey, I'm maddog, the toughest SOB in TNA. I'd like to learn a little bit more about muscles.
Well, sure, I can help you increase your knowledge about how muscles work.
Good. I want to put a couple more muscle pounds on these bad boys. Yeah.
Sure, we can work on that. Well, Mad Dog, I'm going to start off with most skeletal muscles and how they're formed.
Okay.
In most skeletal muscles, there is an origin, insertion, tendons, and the muscles itself. The origins are one end of the muscle. It joins to the bone that remains relatively stationary. On the other end of the muscle, it is called the insertion. It attaches to another bone across the joint.
This is the origin. This is the insertion. Yeah. Oh, I think I am ready to become like Arnold Schwarzenegger now.
A Mad Dog, Arnold was considered a mesomorph. That means he has crazy, freakishly genes.
What the heck is that? Like the Mutant Ninja Turtles or what?
No, a mesomorph is a person who has big muscles and big bones. There are also two other types. An ectomorph is a person who is generally skinny and struggles to build muscles because of their genes. And an endomorph are people who are genetically fat and just large. Genes also have to deal a lot with the amounts of type 1 and 2 muscle fibers. Type 1 muscle fibers have more oxidation purposes like endurance. Type 2 serve greater purpose for short bursts of exercise. For example, Arnold has a lot of type 2 muscle fibers and Armstrong has a lot of type 1 muscle fibers.
So it's a different group of different people then.
Wow, Mad Dog, you catch on really quick.
Thanks, buddy.
Now, Mad Dog, skeletal muscles are very big considered in size. The whole muscle is arranged in bundles called fascicles, each surrounded by a sheath of fascia. And inside the fascia, there is a single muscle cell.
But don't those cells move?
Yes, they contract, making your muscle cells shorter. The myofibrils contain sarcomeres. The sarcomeres are joined together and are composed with a thin structure, which is composed of actin, and a thick structure, which is composed of myosin. Basically, they are tiny rubber bands that make your muscles shorten and relax, allowing you to move your muscles.
Wow, that sounds like lifting.
Well, let's get back to those myofibs I was talking about.
Okay.
Hey.
Hello?
Vince called Mad Dog to a match tonight, so and he was going to explain specific about muscles. Can you kind of help me out?
Yeah, sure. I'll explain the rest. Follow me.
So when do the muscles know when to contract?
Well, they get the signal from the brain. Skeletal muscle cells are stimulated to contract by certain nerve cells called motor neurons. The motor neurons secrete a chemical substance called acetylcholine, ACH. Acetylcholine is a neurotransmitter that causes an electrical impulse to be generated in the muscle cell plasma membrane. To speed up the transmission of the electrical impulse, T-tubules go deep into the cell to stimulate the whole skeletal muscle cell.
Oh, so the whole system's like an electrical circuit.
Yes. Now, Jared, around those myofibrils, there's a spider-like web structure called the sarcoplasmic reticulum. The primary function of the sarcoplasmic reticulum is to store ionic calcium. Inside the muscle cell, an electrical impulse races down the T-tubules to the sarcoplasmic reticulum. Then, once the electrical impulse hits the sarcoplasmic reticulum, it transmits calcium ions into the myofibrils, causing a contraction in the muscle.
So when the motor neuron stops, the muscle stops contracting. So how does the muscle get energy to move?
The muscles get energy to move by stored.
ATP is used first in muscles when they undergo any sort of action or just relaxation. Once the ATP is all used up, which is relatively short, creatine phosphate is then activated. Creatine phosphate is then broken down into muscles to provide additional ATP. This energy lasts about 2 to 7 seconds. Glycogen is a secondary, long-term energy provider for muscles. It is used more in aerobic exercises than ATP and creatine phosphate. It forms an energy reserve when muscles are undergoing strenuous exercise. And once glycogen depletion has been implicated, the use of lactic acid increases, which is where muscles get sore. All three of these energy-rich substances are entered into the myosin, which is a thick filament. From there, they are activated when the muscle is signaled.
Now, are there any other questions that you need to be answered?
So how do muscles tear and how do they rebuild?
Now, muscles tear by muscle stress. Ah!
No. There are two types of muscle recovery, hypertrophy and hyperplasia. Hypertrophy relies on numerous psychological responses. Immediately after exercise, satellite cells activate and begin a healing process that can last up to 48 hours. Satellite cells, located toward the outside of every muscle fiber, fuse together and form new contractile proteins called actin and myosin, the same muscle fiber proteins that tear away during muscle activity. Greater levels of actin and myosin enhance attachments between fibers and promote superior strength production within affected muscle. Hormones also have an effect on skeletal muscles. For example, testosterone induces skeletal muscle hypertrophy, leading to greater muscle strength and power. Information regarding estrogen is limited, but scientists say estrogen does benefit muscle strength by increasing muscle quality rather than quantity.
Thanks for your help, Spencer. I'll be sure to inform Mad Dog.
No problem, Jared. If you need anyone to talk about muscles, I'm the guy.
No.
Go like this.
Drinking
No.
chocolate milk. Doing your body good.
No return. Get in there, man, dog. Get in there, dog.
We're done filming.
Go like this. Act meaner. Yell. Go like, come on, man, get in the zone. Hug it.